Hello YouTube, iFixItAll here, Team iFixItAll. Um, Today's video is about strain relief on electrical wires, whether it would be AC electrical or DC electrical, washing machine, stove, hot water heater, automotive, and when we make connections with these types of connectors. That's a male side butt connector, or a big old ring terminal connectors. I don't know what your language is that you want to use, but let's say you get a look at what's in the box here. And these things, these guys here and here, you get the idea. Those kinds of connectors. And normally what we experience is let's see if I can find a sample here that I can do a little forensics on while we're discussing it. Let's see if I can. Yep, that came off real easy. Normally what we see is we have wire that is stripped. I don't know if I like the way that felt. No, I didn't take any copper hairs with me. Okay. That's blue. I wonder if I shouldn't be using a red on this. Just so it's more correct. Pull this off of here. There we go. Get it trimmed to the proper lengthy. Okay. So let's just pretend like I didn't take the red thing, the red part off. Let's just take a look at what we normally see is the lug is crimped on with this included. You're actually going to be crushing this part. I've got it backwards. And what you end up with is your connection is crimped into turn. You're crimped on the copper wires. Then time marches on and this thing gets wobbly and wobbly. Has anyone ever had this stuff break off right here? That's because you're depending on just the copper to maintain rigidity, where it transitions from insulation to just bare copper to the lug, which may or may not be under moving scenarios. It might be a conductor that's required to be moved around, as like maybe you open a door on an object, or maybe it's your sound system. in your vehicle, and you got your harness that's zip tied along your hatch or whatever the game is. But this stuff has a tendency to just really be weak feeling right at the crimp. And why do we not generally have that problem in the automotive world or in mass production electrical harness manufacturing world? It's because they have something called strain relief on their connections. Let me see if I can show you what I mean about this strain relief business. Okay, so this is a pin that goes in a computer, automotive computer. It's a female pin that transitions into a design that locks in, and then the physical conductor, the crimping action is right here, but there's a second set of tabs back here that's not touching any copper. Hope you guys can see that. See the design I'm talking about. The copper is involved in this crimp right here. And here's your strain relief. That's crimping around the jacket, so that when the wiring is pulled, the strain and effort and tugging on the harness is being distributed at this point right here, because the rubber jacket is reducing any pulling going on where the copper is crimped into the second set of tabs here. I'll show you what a normal lug looks like that we are used to dealing with, and it's these guys. They're generally just hollowed out. They have the plastic end on the end. We crimp, we stick our wire in and we crimp, and that part, but there's no strain relief engineered into it. Here's what I mean by strain relief. This may not exactly be, well, let me do apples to apples. There we go. Okay. It's called a female spade connector here. There's the type that I'm talking about, which is normal, what we normally buy at an automotive store and what have you. But there's another kind of connector that you can start to purchase if you want to be better at your electrical wiring for reducing its failure point if the wiring gets tugged or what have you, because in nearly all professional cases of all harnesses, there's something engineered into these guys called strain relief tabs. So here's what we crimp on our normal lugs that would have a heat shrinkable backer on it. It's just a barrel, and you use your crimper to crimp it. So I'll set this down now. That's our normal cheapy guy. Which brand is ideal on that one? Then there's this guy. Spade connector still. But these other two tabs up here. These two ears you're going to strip your wiring down, and the copper is going to be from here. Copper is going to be exposed underneath these two ears here, from here forward. From here on back is going to be insulation. So these two ears are going to be crimped over the insulation. Let me show you again an example on this automotive connector here. Once I unpin it, if I can, I'll untab it. There we go. This is a specialty type Ford Motor Company connector, but still the attributes of it having strain relief is still present. Notice the copper is showing right here, and it's underneath this section of metal that's crimped over. And then there's these two back ears that are crimped over the insulation. That's a strain relief. Notice how hard that is to bend. It's got rigidity to it. It's following the profile of the rigidity. It's following the exterior insulation bendability. It's not straining on the crimped area of the copper. A lot of times I might sound like I'm talking to you like you're an elementary school student. A lot of people just don't know these finite details of how stuff works, or why should I do anything different? Why do I care? Show me why I need to know this. Well, if you are the guy out there doing these ring terminal lugs, and you don't have a lot of time, but you do want to do better, but you just hate these damn things, and you can't achieve this, but you'd like to achieve something like this, I do have a suggestion. So here goes. Put that there, put this back in where it belongs, because that's a part of a very precious set of a connector group that I have, which is the headlamp switch assembly, headlamp switch connector for a Fox body, Mustang, Thunderbird, Ford pickup, Mercury Cougar, blah, blah, blah. Even in the cheapest of applications, the most cheapest of scenarios, this is a little wire harness that came with a toy years and years ago for one of my boys. But even these, I pulled some barriers to help us see. I pulled them back. Even these guys were crimped with strain relief in mind. Pointer. Take a look-see. The copper is up there, and it's under this section crimped. But then the lug itself has an additional set of ears that's crimped down on the exterior insulation. It's for tugging. It's strain relieved. Well, you want to start doing that with the stuff you have. Here's the connector that does the strain relief. Here's the specialty tool that you use to achieve those crimps. I'll go ahead and perform a crimp here. Got to find the right die. I have to figure out which one is the correct die by eyeballing this. I think it's this guy. And that copper is a little bit long. I'll get something called long copper. There we go. Which one is the right one? I rarely use this crimper, but when I need to, when I need it, I'm glad I have it. Let's see if that's the right one. It might be. I'd rather be in a situation where I'm not saying it might be. I'd rather not be in a situation where I'm saying it might be. I think I was more right here. Center it up. I hope I'm right. Oh. I was wrong. I need to go to a smaller die, which means the next smaller would be over here, which is where I didn't want to be earlier, but I guess it's talking to me now. There we go. All right, so, whoopsies. That needs the next smaller die that came loose. Goosey. Glad it showed me. I wish I was a lot better at using these too. Or this, not these. Sorry. Even I think I'm taking way too damn long. There we go. Okay. Yep. Got her. All right, so that's strain relief crimped. And now I've got these two ears here. And what you do is you can either use your crimpers or study the profile, target what you're after. To me, I would just simply go like this. Now I'm going to roll that over, roll that over, and then I could pick a die that I have on the crimper, or select something fairly generic off of this one if I think I see one that will sort of hammer it home. I'm thinking I'm going to go with this. There we go. Anything better over here? That looks like it'll do a better crimpage. I'm going to try something. There we go. Okay. I'm strain relieved now, and the copper's under the crimp right there, and it transitions to insulation in this general vicinity, and I've got my little ears turned over, and I could do a better job on that, but this is just for the video's sake. These two ears are crimping down on the insulation. I don't really like the way that looks. That wouldn't be my permanent thing. I don't want to spend a lot of time. I just want to get the concept of strain relief down to talk to you about how can you do that. It's bugging me. How can I do better on that? There we go. I can roll that in some more. Yeah, I don't have the proper tool to get the back ears properly done up. If this was like a one-off connection, I would definitely be doing exactly what I'm doing right now. Yeah, I got it much better that time. A lot better. I got a decent little indent on the insulation, proving out that I have some strain relief happening. Over to this world. Let's say you are just simply dinking around with one of these connectors. Big yellow one. Well, I would recommend you kind of wiggle. If you get good at it, you don't have to take this off, but I'm going to take this off just to get the conversation started, because I want you to see what I'm doing. It integrates strain relief into the concept. Notice that the all of this metal here is actually one flat piece of metal. It's just been rolled and formed. And do you see the split right here? Right through here. All right, so that's what I want to focus on next. What I've done is I've taken my copper and I've straightened it out and I've folded it back 180. And I'm going to situate this to where the fold is facing away from the split, so that the copper is there. Now, in this particular instance, I'm most definitely going to trim some. If you if you're just stripping real quick, you'll know that obviously you'll get used to how much you need to strip off before you you can just know right away all you need to do is strip like a 1/4 inch will be good enough, because when this is on, there's a little stop tab inside there where the copper wire can't go any further, because this thing is engineered to stop. There's a little tab in there, and notice my copper is folded down and toward the back. Well, bumping the camera again. Well, now that was just a fit test, but in the real world, you just skinned about a 1/4 inch back. You kind of know that the split's always on the top of this spade connector. You know your split is always on the top. So you just kind of strip your wire, fold it back, orient it, push it in there, take a look down in the hole, make sure you're deep enough, and then you just do what you normally do. You just get her squared up, give her a crimp, and some folks give her 2. Okay. Now you've got strain relief, because you not only crimped the copper, but you also crimped the insulation that's integrated into that whole package. There are those out there that would probably disagree with what I just did, but tell me a better way to give yourself some makeshift strain relief on your connectors. And give her a good tug. Well, see, this stuff here is sensitive. I wouldn't recommend doing what I'm doing, but this is just for the video. I think I've done a real good job there. As a matter of fact, let's just destroy it. Hang on. Okay, so I'm crimping down on the lug. And what do I want to do here? I want to grab it with a pair of pliers. There we go. Don't want to fall on anything. Oh. There we go. Pull it out. That felt like 15 pounds. I was expecting it to be worse. Yeah, looky there. Cool. We get to do a forensics. So look what happened. This is kind of interesting. I ripped off part of the insulation. Some of the copper and insulation stayed with the lug. And some of the insulation got ripped off of here. What's that tell you? Tells you that you had some strain relief, because the rubber was grabbing on the lug, but also the copper was integrated into the crimp. And that's good enough for those low current situations. And it's applicable in many situations. But there's you a a decent strain relief solution so that you could have a better quality connection. That's all, guys. Talk at you later. See ya.